Welcome to an introduction to functions. The goals of this video are to define a function and also to identify the domain and range of a function. A function is just a rule that for every input assigns a specific output. You can also think of a function as a machine in which each input produces a single output. As an example, let's say you own a prepaid cell phone. The monthly cost is a function of the number of minutes that you use. For example, if the cost is 15 cents per minute, your monthly cost will be the number of minutes times 15 cents. So if we think of this box as the function that represents this situation, the input would be multiplied by 15 cents. So for example, if you used 100 minutes one month, 100 times 15 cents would be $15. So the input would be 100 minutes and the output would be $15. If the next month you used 200 minutes, then 200 times 15 cents would be $30. So an input of 200 minutes has an output of $30 and so on. So we can see that for every input, there's only one output. To think of this in a more mathematical way, we could define two variables where one would represent the number of minutes and one would represent the monthly cost. The input is usually x, so we'll let x equal the number of minutes, and we'll let y equal the monthly cost. So if we wanted to write an equation to represent the situation, we could say that the monthly cost y is equal to 0.15 times x. However, when working with functions, we usually use something called function notation, which means instead of writing y equals 0.15x, we can write f of x equals 0.15x. So f of x is equal to y, and this notation here is used to show the relationship between the input and the output is a function. So relating this notation to what we were saying earlier about the input is multiplied by 15 cents to produce the output, we could say that f of 100, meaning 100 is the input into the function, and the output would be $15. And f of 200 is equal to $30. One more connection we should make here is that each of these function values represents a point on the graph of the function. So f of 100 equals $15 would represent the point where x is 100 and y is 15. And f of 200 equals 30 represents the point where x is 200 and the y-coordinate would be 30. So there's a lot going on here, but other than some different notation, it is things that we've already studied before when we had equations in terms of x and y. And there is quite a bit of new vocabulary when we talk about functions. The input, usually x, is called the independent variable, and the output, usually y, is called the dependent variable. Let's take a look at another situation that models a function. Let's say you pay $70 per month for digital cable television, and your cable company offers pay-per-view movies for $3 per movie. We want to write a function that models the total cost of your cable bill for a particular month. But notice in this case there are two components to the monthly bill. There's a variable cost, or the cost that we pay for watching movies at $3 per movie, and then we have the fixed cost of $70 per month for the digital cable television. So to model this function, because we have two components, let's let this first component be the variable cost, or the cost of watching a movie at $3 per movie. So again, this would be the number of movies watched times $3. They call it the variable cost because it varies based upon the number of movies watched. The second component is called the fixed cost because the cost of $70 will not change
regardless of how many movies we watch. So for our function, the input is going to be the number of movies watched in that particular month, and the output would be the amount of the monthly bill. So for example, if you were to watch 10 movies in 1 month, the total cost would be 10 times $3, that'd be $30, plus $70, resulting in a bill of $100. So if we let x be the input, or the number of movies watched, then our output y would be the amount of the monthly bill. So to write an equation for this situation in terms of x and y, we can say y, the monthly bill, is equal to 3 times the number of movies watched, which would be 3x, plus the fixed cost of $70. But because we know this represents a function, using function notation, we can say instead of y, we can say f of x equals 3x plus 70. So for example, if we watched 10 movies in one particular month, we can say that f of 10 would be equal to 3 times 10 plus 70, or 30 plus 70 would be equal to 100, and the units would be dollars. So we can say f of 10 equals $100. Now let's talk about some additional vocabulary when working with functions.
The set of all possible inputs is called the domain of the function. So the domain can be viewed as a set of all possible x values, and the set of all possible outputs is called the range. So we can think of the range as the set of all possible y values. Let's see if we can determine the domain and range for this situation. The cost of a taxi is a $4 flag fee plus $3 per mile. So the $4 flag fee is what you're charged as soon as you enter into the taxi. So that's the flat rate, and then you have to pay $3 per mile after that. So if you took a taxi for 1 mile, you'd have $4 plus a $3 fee, or a total of $7. If you went for 2 miles, you'd have the $4 fee plus 2 times $3, which would be $6, for a total of $10. So if we let x equal the number of miles and y equal the total cost, we would have y equals the $4 fee plus $3 times x, or the number of miles. So using function notation, we'd have f of x equals 4 plus 3x. So now when we talk about the domain and the range, we're talking about what are the possible values for x. And x represents the number of miles the taxi would drive. So we could get in the taxi and then get right out, and we still have a $4 fee. So it could equal 0, but x could never be negative because we can't drive negative miles. So the domain would be any number that is greater than or equal to 0. Now the range are all the possible y values. We're looking at this cost equation. If we go 0 miles, we still have this $4 flag fee for calling the taxi. So the cost of the taxi is going to be $4 or more. So we could say that the range would be y greater than or equal to 4. Let's take a look at another example of determining the domain and range from a situation that represents a function. Here it costs $5 to enter the theme park and $2 for each ride. So if you let x equal the number of rides, and again y equals the total cost, we would have y equals the $5 cost to enter the park plus $2 times the number of rides, or 2x. So using function notation, we replace y with f of x, so we have f of x equals 5 plus 2x. So to determine the domain and range for this situation, let's go ahead and make a t-table. Remember, x represents a number of rides, so x could be 0, 1, 2, 3, and so on. Let's see what y would be for these different x values. Well, when x is 0, we have 5 plus 2 times 0, that's 5. When x is 1, we'd have 5 plus 2 times 1, that's 7. When x is 2, this would be 4, so 5 plus 4, that would be 9. And then when x is 3, we'd have 2 plus, this would be 6 or 11, and so on. So we need to think about how are we going to express the domain and the range based upon these given x values. Notice that x could not be a decimal or fraction because we can't go on a decimal or fraction number of rides. So the domain would be the set of numbers 0, 1, 2, 3, and so on. One way to say this would be to state the domain is all non-negative integers. Now let's take a look at the range. The range are the numbers 5, 7, 9, 11, and so on. So if we were to list these, it would look like this. Now in reality, there is a maximum number of rides somebody could go on in one day. Therefore, there is some maximum cost, but we're not given enough information in this problem, so we'll go ahead and assume this could continue on forever. So the question becomes, how do we express these values in the range? And notice the pattern is a sequence of odd numbers. We could say all odd numbers greater than or equal to 5. So we could say that the range would be all odd numbers that are greater than or equal to 5. Okay, that'll do it for this introductory video. In the next video, we'll take a look at graphing functions to determine the domain and range.